Grade 11 to 12, welcome to this session. Thank you very much for joining me today. And today we're going to be continuing with Euclidean geometry revision. Today we're going to be focusing on Theorem 2, and this is a continuation from the previous session. Okay, Theorem number 2 is state that the angle at the center of the circle, very, very important. The angle at the center of the circle is twice the angle at the circumference, right? Okay, so let me just show you using this diagram, and this is quite fairly easy theorem to know, right? So how do I know? Is it any angle at the center? Will it be 2 times any angle at the circumference? The answer is no, right? So the statement really says if you have an angle subtended by an arc. Okay, let me use this diagram. And this is your arc. Let me use a yellow color. This is your arc, right? Your arc AB, right? It's subtending an angle at what? At the center of the circle. That's the angle, right? AOB, angle AOB, right? So the same arc AB is also subtending another angle at the what? At the circumference. Can you see? It's subtending another angle at the circumference, right? So the theorem states that if you have an arc subtending an angle at the circumference and also subtending another angle at the what? At the center, then the angle at the center, subtended at the center, will be twice the angle subtended by the same arc at the what? At the circumference. Okay, so this is quite an easy theorem because it's just clear as it is, right? So the reason that you give, you just say angle at the center is equals to 2 times angle at what? At circumference. Okay, how can we use mathematical representation for all these 3 diagrams, right? So these are the 3 diagrams that you can expect from this theorem, and it's really quite very easy to see that using your first diagram, and a lot of students struggle to quite see that theorem within these other 2 diagrams, but I'll just show you, right? Just need to understand the theorem. Okay, so as you can see, we have our arc AB, right? This is our arc. Is subtending an angle at the center. What is that angle? It's gonna be angle, let me write it, angle AOB, right? Angle AOB, it means is this angle. What will happen? The same arc AB is subtending another angle at the what? At the circumference, and that is angle P. So what happens? Angle at the center will be 2 times angle at the what? At the circumference. Then we'll just say AOB is equal to 2 times angle P, or rather we can write it more to be more specific, is equal to angle APB, right? So that we show them we are talking about this angle, right? So that's what the theorem states. Okay, so let me show you using these other diagrams, right? Let's come here. So also in this diagram, you have an angle subtended by the arc at the center, right? But this is quite not quite easy to see, but here's your arc is subtending a certain angle at the what? At the center. There is it, right? So that angle subtended at the center, the same arc is subtending another angle at the what? At the circumference. Can you see? At the circumference. Can you see? Then we can also deduce that angle AOB will be equals to what? 2 times angle what? Angle APB, right? And the reason that we'll give is that angle at center is equals to 2 times angle at what? At circum, right? So that's the theorem. Okay, let's also look at this using the last diagram. Okay, so on your last diagram, let's check the arc that is subtending an angle at the center, right? Okay, so here is it. You have your arc AB again, is subtending an angle at the what? At the center. Can you see? It's subtending this angle. It's still angle what? Angle AOB. Can you see? Still angle AOB, right? What will happen? Let's check the same arc. Is it subtending at the circumference again? Yes, there is it. It's also subtending an angle at the what? At the circumference. Can you see the same arc? This one, AOB, is AB is also subtending at the what? At the circumference, right? So the theorem says angle subtended by the arc at the center will be 2 times angle subtended by the same arc, but at the what? At the circumference. And this is theorem number 2. Okay, let's go and check how we can prove this theorem. Okay, so we want to prove this theorem, and it's an exam kind of question. They can just give you this theorem and they say prove it, right? In other words, we are required to prove that angle at the center is 2 times angle at the what? Angle at the circumference. Okay, so we're just gonna prove using both these two diagrams, because there's quite a slightly different approach to proving this theorem from these two respective diagrams. Okay, so I'm just gonna show you how to prove with diagram A and also how to prove with diagram B. And it's very, very important that you learn how to prove this theorem. It's not difficult, it's very simple. Just need to have some key basics about triangles and angles and all that, right? And we discussed that in the previous session as we were doing some geometric key basics. Okay, so in diagram A, we are required to prove that angle AOB, this is the angle at the center, is equals to angle 2 times angle ACB, and this is the angle at the what? At the circumference. Okay, so when we want to prove, we're just gonna write them proving. We want to prove now. We're gonna start with construction. Very, very important, right? We want to prove any theorem, you have to construct so that you can be able to prove it. Okay, so what's the construction now? So the construction here, we now join this radius CO, right? We are joining radius CO and we extend it up until we reach N. In other words, you're just cutting the thing into 2 equal pieces such that this angle will be the same as this angle. So we want to bisect or rather divide this triangle into 2 equal pieces, right? Such that that angle, that side, is the same as that angle. So that's our construction, right? So we're just gonna write for them. We are joining line from C passing through O, which is our center, towards N, right? So that's what we do. We just join a line from C passing through O and it's moving towards N, and that's our construction, right? Remember, from this construction, very, very key is that we are trying to bisect this angle here such that this angle is the same as what? As that angle. So after construction, we can just name those angles, right? So I can name this is angle O1 and this is angle what? O2. I can also name this is angle C1 and this is angle what? C2, right? So I can go and prove now, right? Can go and prove. Okay, so let's go and prove. So when we prove this, it's quite easy, right? Let's see something here. You have this angle here, right? And you have this triangle here, this triangle. What can you do this? Angle O1 is an exterior angle, right? And we talked about exterior angle when we were doing the revision there, right? When we're doing key geometric basics. What did we say about the exterior angle? Is that the exterior angle of a triangle is equal to the sum of the 2 opposite interior angle, right? So it will be equals to angle A plus angle what? Plus angle C1. Can you see? Exterior angle of a triangle is equals to the sum of the 2 opposite interior angle in a triangle. And our reason is simply exterior angle of what? Of triangle, right? Okay, so we can move now, but we know something here, very, very important. Remember, we talked about radius, right? And what did we learn about radius? Is that all radius are what? Are equal. Can you see this is radius? Radius OC is the same as radius OA. Can you see? And what does that imply? It implies that that triangle will be an isosceles triangle. And what do we know? Is that if the sides are equal, if 2 sides are equal in a triangle, then also the base angles will be what? Will be equal. So we can write for them that but angle A is the same as angle C1. And why are we saying that? Angle A is the same as angle C1. And why is that the case? Because these are base angle of a triangle, right? Base angle of an isosceles triangle. They are what? They are equal. And our reason for that is that we are seeing that the radius are equal, right? So we can write for them the radii to show that it's more than one radius. The radii are what? Are equal, right? And we can deduce that angles opposite equal what? Equal sides. Angles that are opposite are equal because the sides are equal, and those sides are our radii. Or someone can just simply say base angle of an isosceles triangle, but you also need to show them which sides are equal so that you can be able to deduce, oh, base angle are also the same, right? Okay, so it means that where there is A, we can go and replace by what? We can go and replace by C1. So it's gonna be C1 plus what? Plus C1, right? And this will be the same as what? It's 2 angle what? Angle C1. So angle O1 is the same as 2 angle what? As 2 angle C1. That is a very, very important statement. Okay, so look at this. Similarly, we can now say similarly, I don't know if that's the correct spelling for similarly. I believe so. Similarly, angle O2, by doing the same thing that we did in this side, we can also prove that angle O2 is also the same as what? As 2 angle C2. Can you see? Similarly, because we just proven that angle O1 is the same as 2 angle C1, right? Angle O1 is the same as 2 angle C1. So similarly, by following the same approach to say exterior angle equals to this angle plus this angle, then we just say those angles are equal because the radius are equal. So base angle of an isosceles triangle are equal. Then we can also prove that angle O2 is the same as angle what? 2 angle C2, right? Then let's go now. Okay, remember we want to prove that angle AOB is the same as 2 angle what? Angle ACB, right? So if I take angle O1 plus O2, why am I adding angle O1 plus O2? Because I know that angle O1 plus O2 are the same as angle AOB. It's angle AOB, right? Will be the same as 2 angle C1 plus 2 angle what? Angle C2. Can you see? But we know that angle O1 plus O2, we can replace it by what? Angle AOB, right? It's actually angle AOB there, right? And 2 angle C1 plus 2 angle C2, we can take out the common factor of 2. Then we have angle C1 plus angle what? Angle C2. Can you see? But we know that angle C1 plus angle C2 is equals to what? Is the same as what? Is the same as A angle what? Angle CB. Can you see? It's the same as A angle CB. Therefore, we have proven that indeed angle at the center, which is angle AOB, is the same as 2 times angle ACB. This is the angle at the center, is the same as 2 times the angle at the what? At the circumference. So it's very quite easy to prove this. So very, very important as we revise. Just a quick recap for this. You first construct, you do a construction, check if you have an exterior angle. We know that exterior angle of a triangle is equal to the sum of the two opposite interior angles, right? Then you can prove that, oh, this angle actually is 2 times angle C1. Similarly, if I do the same this side, I'll get that angle O2 will be the same as 2 angle C2, right? Then we can just add those angles and finally deduce that, oh, really, indeed, angle at the center is 2 times angle at the what? At the circumference. Okay, let me show you how to prove this using diagram B. Okay, so here's your diagram B, right? And they want you to prove that angle AOB is the same as 2 times angle what? Angle ACB, right? It's actually angle at the center, this one AOB, is the same as 2 times angle the circumference there. Okay, so they want you to prove that. Okay, so if we want to prove that, obviously we have to start with what? With construction. So what are we gonna construct? We're just gonna join the radiuses and we extend towards the circumference. Okay, so our construction, we just join line from C passing through the center O, and it moves towards our circumference there. So that's your construction. Just write for them, join line from C and must pass through O towards the circumference, or rather towards N, right? So that's your what? That's your construction. Let's now go to the proof now. So before proving, you have to name your angles, right? And this is very, very important if you have this kind of diagram, right? So I'm just gonna name this angle O1, right? And now it's different. You don't come now and say this is angle O2. It will sort of quite confuse you, and this is quite different from what we did using diagram A, right? So what we're gonna do is we're gonna name this angle O1, and we're gonna name this whole one angle what? Angle O2. And it's very, very important because it will help us to now prove this theorem, right? Similarly, I'm just gonna name this angle C1, and we name this whole one angle what? Angle C2. And we're just gonna start proving now, right? Okay, let's start with angle O1 now. Angle O1, can you see angle O1 is this smaller one here? You have it's an exterior angle of this triangle. Can you see this triangle? Or rather, let me delete the rest of the things there. So angle O1 is an exterior angle of triangle AOC. What do we know about exterior angle of a triangle? Is equals to the sum of the opposite interior angles, right? It means that angle O1 will be angle A plus angle C1, right? Because of what? Exterior angle of what? Of a triangle. We know that exterior angle of triangle is equals to the sum of opposite interior angles. Okay, so we can now move. But we know something here, very, very important. You have your radius. Can you see? AO and OC is also your radius. What do you know about radius? All radius are what? Are equal. So if this is a radius, so you have this kind of a triangle, and we talked about this kind of a triangle when we were beginning with our session 1, right? So you have AOC, and you find that this line is the same as this line. What happens now is that also the base angles will be what? Will be the same, because angles opposite equal opposite sides, right? Angles that are opposite are equal if the opposite sides are also equal, because base angle of its isosceles triangle equal. So it means that we can also deduce that, but angle A is the same as angle what? As angle C1, because what? Because the radii are what? Are equal, and if the radii are equal, it means also the angles that are opposite are equal opposite sides, right? Angles opposite equal opposite what? Opposite sides, right? Yeah, that will be your reason. So we can go now and replace where there is A1, because we are saying angle A is equals to angle C1. So where there is angle A, I can put angle C1, then it's just gonna be angle C1 plus C1. That angle O1 will be what? 2 times angle what? Angle C1. Can you see? Angle O1 will be equals to 2 times angle what? Angle C1, right? We can also deduce that similarly, right? Similarly, we can now prove that angle O2 also, right? Angle O2 also, remember we said this is the whole C2 and this is the whole what? O2, right? We can also prove that angle O2 will be the same as what? As 2 times angle what? Angle C2. We can also prove that, right? Using the same approach. It's just that we don't want to rewrite angle O1 is equals to this one and this one radius, because we already did that in the first step, right? So we can just simply write. Similarly, we can also prove that angle O2 is equals to 2 times angle what? angle C2. All right, so then we can now go and finally deduce, right? So now remember, we want to prove that angle AOB, which is this angle here. Can you see? I don't know if you can see because my diagram is a bit of a mess. Let me just erase this. Let me just erase that and rewrite this angle O1, and this is my O2, this C1, and this is our C2, right? So we are saying we want to prove that angle AOB is 2 times angle ACB, right? So what is angle AOB? Angle AOB is actually the same as angle O2. Can you see? Is this whole angle O2 minus angle what? Angle O1. Can you see? It's actually the same as angle O2 minus angle O1, because O2 is this whole one. If we subtract this smaller one, then we have our AOB, right? So will be the same as what? Remember, we want to prove that it's 2 times angle ACB. So this is quite different from diagram 1, right? Because in diagram 1 we just added them and they gave us that angle there, which is AOB. But if you given a diagram like this, you must be very careful because of your construction and naming, right? So that you can be able to prove that. So the angle O2 minus O1 is actually AOB there, right? It's because of how we did our construction. And also look at this, angle ACB. Angle ACB will also be the same as angle C2 minus angle what? Angle C1, because if we take this is C2 and we subtract this C1 there, will be remaining with that one, which is our ACB, right? Okay, so what is O2 minus O1? So we said this is angle A, what? It is angle AOB, right? It is angle AOB. What is angle C2 minus C1? C2 minus C1, right? So our angle C2 minus C1. So we must be very careful here because we just know that C2 minus C1 is the same as angle what? Angle ACB, right? So, but what is actually angle O2 minus O1? So this is quite a tricky part on this theorem. So what is angle O2 minus O1? We have already said O2 is equal to 2 angle C2, right? Minus, what is angle O1? Angle O1 is the same as what? As 2 angle what? Angle C1, right? If we take out a common factor of 2, you'll have your C2 minus what? Minus C1. Can you see? And we already said our C2 minus C1 is the same as what? Angle C2 minus C1 is the same as this angle there, which is angle ACB. Can you see? Is this angle. If you take C2 and you minus C1, you'll have ACB. It means that where there is C2 minus C1, I'm just going to replace with what? With angle ACB. And that's how you prove that theorem. Indeed, to say angle at the center, AOB, is the same as 2 times angle at the circumference, which is ACB. All right. Okay, let's quickly look at an example, right? For you to conceptualize this theorem. We introduced the theorem and we said the angle subtended by an arc at the center of the circle will be 2 times the angle subtended by the same arc, but at the what? At the circumference. Okay, so we want to now look at these 3 examples, right? So that you can really conceptualize this theorem. Okay, example number 1, they want you to solve for x. So this is my number 1, 2, and 3. They want you to solve for the value of x, y, z. So in number 1, we have to solve for x, right? And what do we know, right? We have an angle at the center. It's very, very important for you to identify this. Angle at the center subtended by an arc. Can you see this arc AB is subtending an angle at the center? What do we know? That angle must be 2 times subtended by the same arc at the circumference. So we can first write to say number 1, angle AOB, which is our angle at the center, will be 2 times angle subtended by the same arc at the circumference. So it will be 2 times angle ACB. And we have to give a reason. Angle at what? At center is equals to 2 times angle at what? At circumference. Right. Okay. So we can now go and replace. What is our angle AOB? Is 130 degrees. Will be equals to 2 times. We want to solve for angle ACB, which is x, right? So to solve for x, we're just going to divide both sides by 2, right? And this cancel this. And x will be equals to 130 divided by 2, which is what? Which is 65 degrees. Okay, so that is fairly quite really easy, right? If you know the theorem. Let's go to number 2. Okay, for number 2, they want you to solve for y, right? We said x is 65 degrees. Okay, we want to solve for y. You must be very, very careful with this kind of diagram, right? A lot of people tend to make mistake, especially when we do a theorem. I think it's theorem 4, right? You'll start to see it's very different, and here you have to be very careful, right? It's not quite obvious as in diagram 1, right? So you have your arc here subtending an angle at the center, right? And you have the same arc subtending the angle at the what? At the circumference. What do you know? Angle at the center, which is our AOB, will be equals to 2 times angle at the circumference, which is our ACB, right? Angle at center is equals to 2 times angle at what? At circumference, right? So that's the reason. So what is our angle at the center is 50 degrees is equals to 2 times. What is our angle ACB is y. So to solve for y, it's quite very easy. We're just going to divide by what? By 2. Then our y will be equals to what? 25 degrees. And it's very true that angle at the center will be double angle at the circumference. So it's very quite obvious to see also if you have the correct answer. Okay, let's move to number 3 now. Okay, for number 3, they give you this diagram, also quite confusing for a lot of students, but hopefully after this session we'll be able to clear that misconception and understand this. Okay, so this is not quite obvious, right? Because you have this big arc now subtending in an unusual way. Okay, so it's subtending this angle at the center, right? Here is it. It's 270 degrees, right? It's not subtending this. Don't say this arc AB this side is subtending this angle in front. No, it's not the case, because this angle in front is subtended by this side now, AB from this side, right? So it won't be true if you are saying it's subtending that side. So it's subtending that 270, this one, right? So then what do we know? The same arc is also subtending the angle at the circumference. Can you see? What? It's also subtending the angle at the circumference. What do we know? The theorem says the angle at the center, angle AOB, will be equal to 2 times the angle subtended by the same arc, but at the what? At the circumference. So angle at center is equal to 2 times angle at what? At circumference, right? Angle circum. So we can substitute angle AOB is 270 degrees is equal to 2 times what is our angle circumference is C, right? To solve for C, just gonna divide by 2. Then we have 270 divided by 2. Then our C is gonna be equals to 135 degrees. So that's actually the application of this theorem. Okay, let's take a look at some quite interesting last example. Okay, so in this last example they want you to solve for x, right? But it's not quite clearly obvious because you'll see why, right? Because the angle is quite inside, right? It's not really subtended by that arc, it's subtended by another one. So we need obviously to check the one that is outside. Then we use the theorem. Okay, how can you solve for x? You must be thinking of theorem 2 now. Why? How do I know that I have to think of theorem 2 when I'm given a question, right? You must check, is there an angle at the center? Is there an angle at the circumference? And what must come to your mind now is that theorem 2 that state an angle subtended by an arc and circumference twice as the angle subtended by the same arc, but at the what? The circumference. So that's how you can actually deduce, or rather know that, oh, in this case, I must think of theorem 2, right? Okay, so similarly to this, we are on to solve for x, but there's a problem here. We know that this arc here is gonna subtend an angle at the center, but this side, right, is subtending this angle, and we don't have it. And we know that to solve for x, if we know this, we can just say this one is 2 times what? Is 2 times the one at the circumference, right? So we must know this angle. I'm just gonna call it angle O1, or rather angle AOB, angle AOC, right? So angle AOC, we know that if we get it, we can easily solve for x, right? So angle AOC plus 150 degrees are angle around a what? Around a point. And we talked about these key geometric basics that you must understand so that you can be able to solve this, right? Angle AOC plus 150 degrees is equals to what? 360 degrees. And these are what? Angles around a what? Around a point, right? So these are angles around a point. We know that they sum up to 360 degrees. Then we can solve for angle AOC now, right? It's going to be 360 minus 150, which is going to give us what? 210 degrees. It means that this angle here is 210 degrees. Now we can use the theorem, right? Angle at the center, which is our 210 degrees, is equal to 2 times angle subtended by the same arc but at the circumference, and we can see that is x, right? So we give a reason. Angle at center is equal to 2 times angle at what? At circumference, right? So we can clearly solve for x. Quite very simple. We divide both sides by what? By 2, right? So 210 divided by 2, our x will be equals to 100 and what? 105 degrees. Okay. Okay, grade 11 to 12. This marks the end of this lesson. We were doing theorem number 2. Angle at the center is 2 times angle at the circumference. Thank you very, very much for joining and watching this session. I hope you learned something. If you have any question, just drop down your comments and let us hear what you suggest. Okay, that's all from me. Coming up next is theorem number 3. We'll be focusing on theorem number 3 in the next session. It will quite be a short session because theorem number 3 is not quite really long. Okay, otherwise that's all for me. Thank you very much and goodbye.